So now we've really got our heads around the differentiation process, we're going to look at anti-differentiation. Of course, this should be familiar from Methods 2 last year. We're just going to go into having a look at the way we go about it and some of the applications and how the indefinite integrals differ from definite integrals, which we talked about in the last video. So just to start us off, anti-differentiation is very simply reversing the process of differentiating. So just to illustrate this, if you have a function f of x equals x squared, okay, we know that the derivative of this f prime x is 2x. Okay, so that's going this way where we differentiate. So differentiating that way to find the derivative. If we go back the other way and anti-differentiate, then we can say that the antiderivative of 2x is x squared. Okay, so that sort of leads us to saying, well, the antiderivative, or the integral, of 2x dx, so with respect to x, is x squared. Okay, now just a word of caution, we do need to be careful with this, because we know that when you differentiate, we lose a constant. Okay, so if we have y equals x squared plus 1, or we had y equals x squared, or we had y equals x squared minus 35, the derivative of all of these functions is 2x. Okay, because these constant, or this constant and this constant disappear, and there wasn't one here. So when we integrate, we don't know what those constants were. So we take care of that by saying, well, the integral of 2x dx, we know it's going to be x squared, but there's some constant plus c. Okay, and if you're in my class last year, I would have told you a sad little story about coughing, and if you're in my class this year, I'll probably tell you at least once about that story. But yeah, you must remember plus c. Okay, everybody forgets it. We forget it. I'll forget it when I'm doing problems on the board. Okay, you can remind me. So just try and remember plus c. And the way we determine that is by extra information that we have about the original curve, which we'll talk about in some examples a little bit further down the track. Okay, now let's have a quick chat about indefinite integrals. So last time we talked about definite integrals as being the area under a curve over a defined interval. So we had something like this, and if you had a curve and we said, okay, well, let's look between, say this is 1 and 2, and we wanted to find that. If this is f of x, then the definite integral is the integral between 1 and 2 of f of x with respect to x, and that gave us that area under the curve there. Okay, an indefinite integral is just the antiderivative of the function in general. Okay, so this idea of in general means it's sort of over the whole domain of the function. Okay, and we may or may not be able to determine what the constant is with that one. All right, so for example, an indefinite integral, so if we've got f prime x is 2x, then the indefinite integral, so indefinite integral will be where we integrate 2x dx, and that becomes x squared plus c. So this is our constant that we can find if we give it a point on this curve. Okay, the definite integral, or an example of the definite integral would be, well, let's say we're going between 0 and 3 of 2x dx. Okay, and what you'll find is that's actually 9 units squared. So you'll see that the indefinite integral gives us a function, whereas the definite integral gives us an area. So it's actually two quite different things. Now you can do this on your class pad, which is always really handy. So if we'll do the indefinite integral. We do 2x, okay, go up, highlight, interactive, calculation, pick the little integration sign. We want indefinite, okay, and it'll just tell me that it's x squared. Now, word of caution, it doesn't put the plus c there for you. Okay, so if you're then going to drag this down and use it for something, you need to make sure that you add the plus c or that you solve for the plus c. Alright, so you can't trust your class pad blindly, but it will do that bit for you. If you can just remember plus c, then it'll do all the sort of the grunt work for you. The other way you can do it, which I showed you in the previous video, but I'll just go through again, is to do a definite integral. So calculation, and now we pick definite, and then we say we want to go between 0 and 3, and that gives me my answer of 9. So that's your area under the curve of 2x between 0 and 3. So that's the difference between indefinite and definite integrals. Okay, so in general, what we found is that when you are integrating a function of the form x to the power r, then what you need to do is raise that index by 1, so it becomes r plus 1. You then need to divide the whole function by that r plus 1, because remember, if you do this in reverse, you bring that down. Okay, so that needs to cancel out with this denominator here, and then always remember plus c. Okay, and we do say that for this one, r cannot be -1. All right, because then you end up with funny things happening here, because you end up with power of 0. Okay, so this doesn't work for 1 over x, that's a different case. Okay. All right, so let's have a look at a couple of examples. Pretty straightforward one to start with. All right, we want to find the general antiderivative, or the indefinite integral. So when you see this, you need to think plus c. Okay, write it down if you need to, circle it, whatever it takes. So basically what we've got is we know that y prime is 3x to the power of 5. All right, and we want to integrate that. So y is going to be raising, well, we just start with the 3 there, leave it alone. Okay, then we want to raise this by 1, so that goes up to 6, and then we want to divide by the new power, 6. All right, and then we can cancel that out. So what we should get is x to the power of 6 on 2. What have I forgotten? Plus c. See, told you everyone forgets. All right, so plus c always needs to be there. Now, you can always differentiate it to check it. Okay, remember way back in sort of year 9 when we started teaching expansion and factorization of brackets? We said if you expand it, then you factorize it, or if you factorize it, you can check it by expanding it. You can do the same thing. So if you differentiate it to check, so we've got y is x to the power of 6 over 2 plus c. Okay, the derivative of that, bring that down, 6, reduce the power by 1, 5 over 2, c disappears, that cancels out, 3x to the power of 5. Is that what we started with? Yes, it is. There, you got it right. Okay, so as you get better at this, you won't need to do this check, but it's always a good idea. Just a quick self-check. It takes a couple of seconds, and you know that you've got that answer right. Okay, a couple more. So this one, we're now using some negative and fractional indices. So the first one, if dy dx is x to the -2, okay, then the integral of that, so we're integrating x to the -2 dx. So we're going to increase that by the 1, gets up to -1, okay, and divide by our new power, which is -1, remembering plus c. Okay, so what that gives me is -1 on x plus c. Okay, I can differentiate that to check. Alright, and then for b, so that was a, and then for b, same thing. We've got dy dx is 3x to the power of a half. So the integral of that, 3x to the power of a half dx. We want to start with 3, we'll leave that where it is. We want to raise that by 1, which gives me 3 on 2. And then we want to divide by 3 on 2, which is the same as multiplying by 2 on 3. Okay, so we can multiply by 2 over 3. Those cancel, and you end up with 2x to 3 on 2. This is something clear. 3 on 2, you've got to have your plus c. And then again, you can differentiate this in order to check that you got what you started with. Okay, so always do that self-check, at least to start with, until you're really confident. Okay, a couple of rules just to sort of go through. If you are anti-differentiating the sum or difference of two functions, so you've got the integral of fx plus g of x dx, then you can separate those out. So similar to when we were differentiating, you can do them sort of one term, like one function at a time. So that works for sums and also for differences. Okay, so just integrate them separately. If you've got a scalar multiple, so you want to integrate a function and it's multiplied by some scalar, where k is a real number, okay, a real constant, then you can pull that out first and then integrate. And you'll see how we do that a little bit later on. It's pretty straightforward. It just sort of makes life a little bit easier for you. Okay, so let's find this one. So this is one we've got a number of different terms and we want to integrate each one. So basically you just do them separately. Alright, so we have, we want to find the integral of 3x squared plus 4x to the minus 2 plus 3 in terms with, sorry, dot dx, and we want to set those up. So we're increasing, if we just deal with this one, we're increasing the power by 1. So start with the 3, just leave that there, and then divide by the new power. Okay, now you should really be able to look at that and go, well, I know that the integral of that is x cubed, but I'm just sort of stepping you through the process just to see, so you can see what's going on. Okay, same thing with this one, leave the 4 there, increase that by 1, divide by -1. Okay, and then this is a constant, so this is just going to be 3x, and then of course plus c. Alright, so when we just write that out a little bit more neatly, we have x cubed, plus, take 4 over x plus 3x plus c. Okay, differentiate to check. Alright, and in terms of finding these unique functions, so I mentioned that we can find the value of the constant if we've been given information about a point on the function that is the antiderivative. So, for example, we had our integral of 2x dx, and we know that that's x squared plus c. Okay, so what that means is the function, the antiderivative, if we have our Cartesian coordinates, so Cartesian plane here, it could be just x squared, like that. It could be x squared plus something. It could be x squared take something. Okay, we don't know unless we're given a point. So if we are told that there's a point here, and we're given the coordinates, just call that AB, then we can substitute those into here, into our f of x equals x squared plus c. Alright, we can put a and b, because this would obviously be, that would be b, that would be a squared plus c. We've been given these two, we can solve for c. Okay, so it just means if you're given a point on the function, then you can substitute that into your antiderivative and you can find the value of c. Okay, so here's one where we're going to do exactly that. So we've been told the derivative. We know that f of x is going to be the integral of this. So x to the power of 4 over 4 plus 4x to the 3 over 3 plus c. Okay, so that's my integral, but I also know that when x is 0, the value of this function is 0. So that's 0 when this is 0, and this is also 0. Okay, plus c, therefore c must be 0. Okay, now it says find f of x, so therefore f of x equals x to the power of 4 on 4 plus 4x to the power of 3 on 3. So if it says find f of x, make sure that you state f of x, you don't just sort of leave it here. Alright, so most of the trouble comes with this when we start looking at applications questions and questions in context. The maths is not difficult, but sometimes extracting the data or the information that you need is, or really sort of understanding what the question is telling you or what it's asking you. So one thing to remember is that the derivative of a function is the gradient. Okay, never lose sight of that. When you're talking about differentiating, what you're doing is finding the gradient, okay, of that function at any point. So it does mean that sometimes teasing out the meaning can be a little bit more challenging. Once you've got that, the maths is actually pretty easy. Use sketches if you need to. Okay, I'm a huge fan of sketching things, drawing things out. You know that if you have a function like that, then you know that it's going to be linear. Okay, you can work it out from there. You can start matching up your stationary points and things. So it helps. Right. So with this example, the gradient is given by 2x, and so that means the gradient, that's your derivative, that's your f prime x. Okay, and the curve passes through the point that, find the equation of the curve. So we want to integrate that. We know that's going to be x squared, and we know it's plus c. Okay, and then we can substitute this in. So 4 equals minus 1 squared plus c. So therefore c equals 3. So therefore f of x equals x squared plus 3. Okay, so not difficult, but you need to understand that when it says the gradient of the tangent is given by this, it's saying that that is your derivative function. Right, so in summary, antidifferentiating is simply the reverse process. An antiderivative is also known as indefinite integral. Okay, so this is actually the general antiderivative when we're not talking over a specific interval. In all cases, constant must be added, plus c. Okay, and then you can find that constant if you've been given further information. Application in context is vital to your understanding. Okay, it's always the worded questions that trip students up, so really focus on those ones.